Hello everybody and welcome back to Creation Myths. I am really excited for this one. This is a topic that I've been meaning to cover for some time. Today we are talking about the creation myth that pedigree mutation rates prove a recent creation. Now the creationist claim here is pretty simple. It goes something like this. This is not a direct quote from any specific creationist or article, but this is a pretty close paraphrase of the kind of thing you're going to hear from young Earth creationists when it comes to mutation rates and specifically pedigree mutation rates. Something like this. Directly observed pedigree-based mutation rates prove that mitochondrial Eve or Y chromosome Adam, Noah, existed 4,000 to 6,000 years ago. Evolutionists want to use unobserved phylogeny-based mutation rates to verify their preconceived evolutionary timeline. That's pretty close to what you're going to hear when you hear this claim from creationists. Basically, the idea is that you can look at pedigrees, specifically parents and offspring. You can look at the differences between them. That tells you the one generation mutation rate, and then you use that to work backwards in time to calculate how distant in the past we needed to have our Y chromosome or mitochondrial common ancestors. This work comes mostly from Dr. Nathaniel Jeanson, and he has two fake peer-reviewed papers on this in the Answers Research Journal, which is the Answers in Genesis, essentially blog masquerading as a peer-reviewed journal. So these are the two papers right here. They're going to be linked down below, and whenever you hear other creationists talking about this topic, the pedigree mutation rates getting you a recent date for the mitochondrial and Y chromosome common ancestors, they're basically just cribbing from Jeanson's work. They're more or less paraphrasing the work that he has done. And I use the word work here kind of lightly because, Jeanson's just misrepresenting other people's data. He's just doing bad calculations and not actually collecting any data, doing any actual, science himself. But that's a story for another day. Let's continue. Now, before we go any further, we need a little bit of background to understand what the claim is and what the problem is here. So we have two different ways of kind of looking at the histories of organisms. If we're dealing with individuals, the tool we're going to use is called a pedigree, which is illustrated right here. A pedigree is basically a family tree. It's a representation of the ancestry of specific individuals. So in general, when you read a pedigree, the generation at the top, you read horizontally, each row is a generation. The generation at the top is the oldest, the present generation, or the most recent generation, is at the bottom. Squares represent males, circles represent females, horizontal lines represent mating events. Okay, so you can read this and see you've got grandparents, you've got their kids, and then these two individuals had some kids right here, right? So that's a pedigree. It's looking at the history of individuals and their ancestry. Now, a phylogeny, or a phylogenetic tree, is all about the evolutionary history of groups and their relatedness to each other. So here, again, you're looking from the past up top to the present at the bottom, although you'll often see these in different orientations. They might be triangular or even circular. So you have to, the orientation is not consistent here, but they always show the same thing. They show, common, as long as it's rooted, they always show the same thing. The root indicates the common ancestor for everybody on the tree. So you have your root, that's your most recent common ancestor for everybody on the tree, and then the branching pattern shows the pattern of descent. Importantly, these lines do not represent individuals. These lines represent groups, taxa, right? They could be species, they could be phyla, they could be whatever level in your hierarchy, but they're going to be the evolutionary histories of groups is what's being represented here. Now, creationists like to use pedigree mutation rates because they're usually faster than what creationists will call phylogenetic mutation rates. To be clear, we're not looking at different mutation rates. Mutations occur at whatever rate they occur at, and then what we're really talking about is different rates of mutation accumulation. And typically, if you look at a pedigree, that's going to imply more rapid rates of mutation accumulation compared to a phylogenetic tree, which usually spans a longer time period, more than just one or a few generations. That faster rate allows you to converge at the common ancestor in the more recent past, so creationists prefer to use pedigrees, and they'll say dishonest things like that. Oh, well, we assume common ancestry with chimps when we're doing the phylogenetic calculations, which is not true, but that's the kind of thing they'll say to discredit the use of these phylogenetic mutation rates. So let's talk about how creationists go about calculating their mutation rates here. I'm going to use one of Jeanson's publications, the mitochondrial DNA one from 2015, as an example. And again, that's linked down below if you want to subject yourself to the full paper. What he does here is he takes 3 papers, he pools the number of pedigrees of generations, because each pedigree that he looks at, it's just parent to offspring. So he looks essentially at the number of generations, and he looks at the number of mutations, and he just divides, right? So he says 63 mutations divided by 398 generations equals 0.16 mutations per generation, which equals approximately 1 mutation every 6 generations. What creationists will often do here is take whatever data they get from the papers they're using or misusing, and they're going to express those mutation rates that have been observed by somebody else and published elsewhere in, the legitimate peer-reviewed literature. And they're going to reinterpret those as, 1 mutation for every X generations or X number of mutations per generation. So what we're going to do here is I'm going to show you the math on how they then calculate a young Earth timeline using numbers like this. Here's what they do. They're going to take, it's about 6 generations per mutation times 60 mutations, and the reason it's 60 is this. The maximum divergence in the mitochondrial DNA between any 2 people on Earth is about 120 nucleotides, and we're trying to work backwards from the present to a common ancestor. So if you take those 120 differences, you have one lineage to person A, another lineage to person B, and they each have to accumulate 60 differences to get your total of 120 differences. So those 120 differences split across 2 lineages means we need to accumulate 60 mutations maximum per lineage to account for the maximum amount of divergence that we observe in the human mitochondrial DNA. So we take our 6 generations per mutation, we multiply by 60 mutations, and that gives us 360 generations. Then we take those 360 generations, we multiply by about 20 years per generation as an average, and that gets you 7,200 years, which is, in the ballpark for a young Earth creation timeline. Really what the young Earth creationists want to aim for is 6,000 years, and they go about this in a couple of different ways. Nathaniel Jeanson, for example, he'll say, well, maybe it was 15-year generations instead of 20-year generations. Or he'll say, yeah, I measured 0.16 mutations per generation, but I think some, and I use the term measured lightly there, but, measured 0.16 mutations per generation, but maybe some lineages are faster. They're 0.2 or even 0.3, and that takes this, this 7,200 and compresses it into your 6,000-year timeline. That's the kind of math that creationists do in order to calculate their time in the past for the common ancestor using the number of generations and the number of mutations in these pedigree studies. Before we go any further, I want to talk about all of the problems with this that we're going to ignore. We're going to focus on one very specific problem with this argument. There are a lot of problems with this argument, some of which I have already covered at some length, and I'm just going to mention them here. Because we're going to ignore all these other problems that I'm going to go through real fast. I'm just going to say, hey, here's a problem, but we're not going to worry about that here. That's not the point. Any one of these problems that I'm going to mention right here is enough to invalidate what the creationists do to calculate their recent dates for the Y chromosome and mitochondrial most recent common ancestors. But like I said, any one of them could be its own video. Some of them I have videos on specifically. They're not the focus of this video right here, so I'm just going to run through them really fast, and then we'll get on to the actual problem I want to point out with the creationist use of their pedigree mutation rates. So the first problem we're going to point out is that they are misunderstanding or they're deliberately misusing the concept of MRCAs. Now, MRCA stands for Most Recent Common Ancestor. It's the most recent point in the past where you could work backwards, look at all the individuals that exist right now, work backwards in the past to the point where they all converge in a common ancestor. If you look at this figure right here with the dots, the bottom row represents the present, the top row represents the distant past, and the colors represent ancestry. So all the blue dots share an ancestor. So if you work backwards from the present backwards to the past, you see the blue dots converge at the pink dot right there. I made it pink so it stands out. That's the most recent common ancestor for this generation right here that currently exists in this hypothetical population. The most recent common ancestor is not the first member of a species. You can see that this ancestry continues back past the most recent common ancestor. The MRCA is also not the only individual alive at the time they existed. You could see there's a whole population that existed at the time of that MRCA, but they're the only ones that have living descendants. And it's also not the case that the TMRCA, the time to most recent common ancestor, equals the origin of the species. So we see going from the extant group back in time to when this most recent common ancestor existed, that distance in time, that's called the TMRCA, time to most recent common ancestor, that does not tell you when that species originated. It just tells you when that most recent common ancestor existed. And importantly, that point is not fixed in time. If you were to go back to an earlier generation, to this generation, or this generation, your common ancestor is going to be in the more distant past. As time moves forward and lineages go extinct, which is to say they don't have descendants, then your most recent common ancestor is going to move forward in time. Creationists basically ignore all of this and want to say, like, this specific point in the past, this specific person, that's the most recent common ancestor, the end. We're not going to talk about that. I've talked about that before. Not the problem I'm pointing out in this video. We're also not going to spend time on the problems creationists have with autosomes. The mitochondrial DNA, the mtDNA, and the Y chromosome, or most of it, are haploid, which means they're non-recombining, right? They don't do the crossing over thing with other DNA. As a consequence, the time to most recent common ancestor for those parts of the genome is more recent than the rest of the genome, which is to say the autosomes in the nuclear DNA. Those are chromosomes 1 through 22 that have pairs. They're diploid, and they recombine. So their effective population size is larger, which means their time to most recent common ancestor is in the more distant past. So even if you take all the creationist work at face value, when it comes to the mitochondrial or Y chromosome most recent common ancestors, the autosomes still put the origins for humanity way back into the more distant past, even when you use the exact same techniques that creationists use for the Y chromosome and mitochondrial DNA, and that's even when you account for young Earth creationist shenanigans like created heterozygosity. It doesn't work, but that's not the focus of today's video, so we're not going to worry about it. We're also not going to dwell on how young Earth creationists conflate the mutation rate with the substitution rate. This goes back to Dr. Nathaniel Jeanson when he admitted to me, when I talked to him a couple of years ago, he just straight up admitted, quote, I'm using the mutation rate as the substitution rate. Take a look if you don't remember.
And I'm treating the mutation rate as a substitution rate, that this rate is consistent.
Thank you. I still can't believe he admitted that, because that invalidates basically all of this work. The mutation rate and the substitution rate are only equivalent in the strict absence of natural selection, and natural selection obviously exists. Dr. Jeanson has written at length about how natural selection is a real thing when he's arguing against the Institute for Creation Research and their continuous environmental tracking idea. He knows that natural selection is real, but yet he claims that the mutation rate and the substitution rate are the same. Those two positions are directly contradictory. Not our problem for today, so we're not going to spend any more time on it. We're also not going to worry about how we have direct confirmation of phylogenetic mutation rates that creationists don't like. We have cross-referenced phylogenetic rates of mutation accumulation with documented historical events with known dates. So like right here, if you look at the present and you have a certain level of divergence across those currently existing populations, and you know when they diverged from each other because that is an event that happened in recorded human history, then we can calculate the rate of mutation accumulation over that time. We've done this for a whole bunch of things. One of my favorite papers ever documents this. It's this paper right here, Correcting for Purifying Selection, an Improved Human Mitochondrial Molecular Clock, that's linked down below. I've also talked about that elsewhere. Plenty of cool details in that paper. I encourage everybody to check it out to show that we have direct confirmation of the validity of these slow mutation accumulation rates. But that's not the topic for today's video. And of course, we have to talk about how we're not going to talk about somatic mutations. So we have kind of two sets of mutations in the human body. You have germline cells, right? Those are the cells that make gametes. So the mutations there can be inherited. Somatic cells, all of the other cells in your body, those don't make gametes. That's like your skin cells, your muscle cells, your neurons. So mutations that occur in those cells are never inherited by the next generation. So when you're calculating the time to the most recent common ancestor, only those germline mutations that can be inherited from parent to offspring, those germline mutations are what you care about. Those are relevant. But single generation pedigrees, like the ones I showed you before in the studies that Nathaniel Jeanson uses, those conflate germline and somatic mutations. The authors of the study that Jeanson uses to get his mitochondrial mutation rate acknowledge that they didn't distinguish in their data between somatic and germline mutations. Jeanson takes all of them and effectively treats them all as germline mutations. That alone invalidates the entire methodology, because obviously if you're bringing in all of these mutations that are not relevant to what can accumulate over generations, you're going to vastly overstate the mutation accumulation rate. But that's not the topic of today's video. And we're not going to talk about the problems with coding versus non-coding regions of the mitochondrial DNA. Many pedigree mutation studies only deal with the non-coding region of the mitochondrial DNA, and this region exhibits a higher mutation accumulation rate than the rest of the mitochondrial genome. You can actually see that mapped out here. It's this region right here called the control region, and you'll notice there's three little bits in here: HV1, HV2, and HV3. HV, what does that stand for? That stands for hypervariable. Hypervariable compared to what? Hypervariable compared to the rest of the mitochondrial genome. So if you have studies that are specifically focusing on the hypervariable region and the mutation rate there, can we generalize that mutation rate to the rest of the mitochondrial DNA? It's self-evident that we can't. That's how we characterize those regions as hypervariable. They accumulate mutations at a faster rate than the rest of the mtDNA. But of course, young Earth creationists, in the course of misusing their pedigree studies, want to extrapolate those mutation rates to the entire mitochondrial genome. Obviously, that's inappropriate. That invalidates their conclusions, but that's not the problem that we're pointing out here. And of course, it's not the topic of today's video, but as creationists do, Dr. Nathaniel Jeanson employs hilariously bad methods when calculating the mutation rate for both the mitochondrial DNA and the Y chromosome. There was actually a piece written in response to this article by Dr. Jeanson called "Creationists Invent Their Own Mutation Rate." The original is not available, but it is available on the Wayback Machine. That's linked down below. And then I've talked about this travesty before, about how Jeanson derived his Y chromosome mutation rates from this figure by blowing it up and using the scale bar of 50 mutations to figure out for each father-son pair how many differences there are. I had a conversation with Dr. Herman Mays about this, and Dr. Mays has written about this in some detail. That's linked down below, so you can check that out if you want all of the awful details in terms of those, let's call them, calculations. Now, I want to be clear about something here. We're going to do just a little bit of math later on in this video, and the way we're going to do it is technically wrong. So if you're an evolutionary biologist, a population geneticist, and you're watching this and you get to that later part in the video and you're going, Dan, what are you doing? That's not how you do that. I know that's not how you do that, but I'm going to do it the way that young Earth creationists do it. I'm going to do it the way Nathaniel Jeanson does it. The point of doing it that way is to play by the creationist rules, right? We're going to play on their field using their rules, and we're going to show that they're wrong anyway, right? That's the point of this exercise. So now we can finally get to why creationists are wrong, aside from all those other reasons that we're not going to talk about, not the topic of this video. The first thing we're going to point out for why creationists are wrong when they use pedigree mutation rates to justify a young Earth is that they're cherry picking. It's not more complicated than that. They like some studies, they dislike other studies. And I know this is shocking, right? Like, stop the presses, creationists are cherry picking. But it's really important and really interesting to see exactly what they're doing here. In this context, creationists like to use single generation pedigree studies. Pedigree studies that basically show parent, offspring, how many differences, that's the single generation rate. These two papers that are on screen right now are the main papers that creationists are going to use to do this for mitochondrial DNA, right? It's this Parsons paper from the late 90s and Ding 2015. That's the one that Jeanson leans on in his Answers Research Journal publication. These two studies show approximately the same thing of about one mutation every 6 generations, give or take, but they're in the same kind of ballpark, which if you extrapolate that backwards, like I showed you earlier in this video, that gets you to approximately, a young Earth timeline for your mitochondrial most recent common ancestor. For the Y chromosome, they're doing similar things using these two papers. These are the two that Jeanson cites in his Answers Research Journal article. It's also the two that he leans on in Traced, his book from just a couple of years ago. Now, these are Y chromosome rather than mitochondrial DNA papers, so the numbers are going to be different, but we're using the same basic approach, right? So you've got the creationists are looking at single generation pedigrees to extract the single generation mutation rate. And this is just an excerpt from the Jeanson paper that uses these two studies. He says 24 Dutch father-son pairs, 6 Estonian father-son pairs, right? It's all about one generation mutation rates. That's the kind of the key thing that links all of these papers together. So that's the cherry picking. That's one side of the equation. They're leaving out data. They're just ignoring a bunch of other studies. The second part of the equation is, what do those studies actually show? Well, if you look at these other pedigree studies, it turns out they refute the young Earth creationists. The reason is that the studies the creationists ignore are multi-generation pedigree studies. They're still directly observed mutation accumulation rates, just like creationists say we ought to use. But they go back multiple generations, in some cases hundreds of years. And oops, they all show a slow mutation accumulation rate. So I'm going to show you some examples, and these papers are linked down below, so you can check them out yourself if you want. These are mitochondrial DNA pedigree studies, and remember, the fast rate that creationists like, that you have to use to get to your young Earth timeline, is about one mutation for every 6 generations. So we can look at this 1998 paper, Sooooooo et al. This is looking at the Tristan da Cunha lineage. That island was uninhabited until 1816. And we can trace current inhabitants back to those founding members. That study found about one mutation every 36 generations. Then we have King et al., 2014, identification of the remains of King Richard III. So we are now going back to the 1400s. We have 2 living descendants, and it's a total of 36 generations going back in that mitochondrial lineage from King Richard III. And just coincidentally, it works out to the same one mutation for 36 generations in that study. And then a more recent one that I really like, Connell et al. 2022. This is looking at the Norfolk Island population. And there's kind of 2 numbers you could get from this. And again, we're using the creationist methodology here, looking at how many mutations, how many pedigree generations did they look at. And if you use kind of the broader data set you get from this study, one mutation every 38 generations, that may include somatic mutations though. So if you use kind of the more restrictive data set, it reduces the rate to one mutation for every 172 generations. Now what we can do right here is we don't have to worry about, do we use the 38 or the 172? We'll just use the 36. We'll use the fastest rate, and we're going to do the math the way creationists do the math. So let's do that math real fast and see where this puts us in terms of our time to most recent common ancestor for the mitochondrial DNA. Let's see what we get when we use these other pedigree studies, the ones that creationists ignore. So let's take our 36 generations per mutation, multiply that by 60 mutations, like we talked about before, multiply that by 20 years per generation. On average, I think that's a fair average generation time, and we arrive at 43,200 years, which you may notice is in excess of the young Earth creationist timeline of approximately 6,000 years for the mitochondrial most recent common ancestor. We can do the same exercise for the Y chromosome. Jeanson calculates a Y chromosome time to most recent common ancestor of about 4,500 years, and while he uses those 2 studies that I showed you before, which are here on the right in red, he ignores 2 other studies that involve deep pedigrees, pedigrees that go back many generations into the previous century. They're Zhu et al., 2009, and Helgeson et al., 2015. And if you include those studies, the mutation rate is 10 times slower than the single generation rate that Jeanson incorrectly derives from his studies up here. So your time to most recent common ancestor for the Y chromosome, it's not 4,500 years, it's 45,000 years. Again, well outside the young Earth creationist timeline. Now, Jeanson's justification for this is that these studies are low coverage. They're only 15 or 12 times coverage, meaning how many times do you sequence each base in the genome, whereas the two that he uses are high coverage studies, 35 and 40 times coverage. And it's true that 35 and 40 coverage are better than 15 or 12 times. That is true. And you're probably going to catch some mutations with 40 times coverage that you miss with 12 times. But we can also do that math and figure out what that expected ratio of missed polymorphism is, without having to just toss out the whole study. The other thing here is that it's pretty rich for Jeanson to get, picky about the methods here and exclude these studies for having not low coverage, but lower coverage, when we know that the numbers that he has for this Moretti study are just straight up wrong. We know they're wrong because the authors of the paper that he used, the Moretti et al., those authors told us they're wrong because Herman Mays asked them. Because they didn't actually report this per base mutation rate. That wasn't the point. They were looking at structural changes in the Y chromosome DNA over generations, and they actually didn't do the kind of quality checks that you need to do when you do DNA sequencing to account for the errors in the sequencing process. So the error rate of the sequencing, because they didn't correct it, is actually indistinguishable from the mutation rate that Jeanson documented. Okay, so we can't distinguish between the mutations that Jeanson is claiming are all valid mutations that actually happened in a single generation and artifacts of the sequencing process that they uses. We can't distinguish those things according to the authors of the study that Jeanson is misusing to get his fast pedigree mutation rate. So I don't think he ought to be throwing stones from his glass house when it comes to the methodology of calculating the mutation rates. And that basically wraps up our story for this topic. Why shouldn't we take creationist claims about pedigree mutation rates and the time to the mitochondrial and Y chromosome most recent common ancestor at face value? Because they just ignore the pedigrees that disagree with them. They do the math wrong, and they ignore the pedigrees that disagree with their desired conclusion. If you include those pedigrees in your data set, you exceed the young Earth timeline. The end. That's it. Anytime a creationist brings up pedigree mutation rates, I want everybody watching this to be able to say, hey, you're leaving out data. What about these other pedigrees that you're ignoring? What's the time to most recent common ancestor if we include those? And the answer is way too far in the past for young Earth creationists. But we're not done yet. We have one more thing to talk about because it's funny, and we like ending on a lighter note here. So as a bonus, we're going to talk about when creationists are accidentally correct. Because sometimes creationists get a little out over their skis and they forget to cherry pick their pedigree mutation rate papers, or they don't know any better, which I think is the case in the example I'm going to show you. So for reference, the mitochondrial time to most recent common ancestor, the young Earth creationist range is 6,000 years, give or take, and the correct range is 60,000 to 200,000 years, depending on your data set and your methodology. Now I'm going to show you a screenshot from a comment on YouTube from our friend, esteemed evolutionary critic, Rawmat. This is a really long comment, and it's really hard to parse, because Rawmat, he doesn't know things. He doesn't understand the words he's using and the concepts that he's talking about. And I know it seems like I'm picking on Rawmat a lot lately, and I think I am, just by chance. But, that's okay, because, he's a tool. He deserves it. He's a liar. He's a hack. Rawmat deserves it. So we're going to pick on Rawmat some more. So this comment, it's a mile long. The whole comment, I couldn't fit in one screenshot. I have to have 2 screenshots to get the whole thing. And it's very convoluted. I don't actually know what he's saying at certain points of it because he conflates words that don't mean the same thing, and he's ambiguous in his language in parts of it. But what it seems like he's doing is he's taking a bunch of studies and pooling the different mutation rates together to get I think he's talking about whole genome pedigree mutation rates, because he cites at least one study in there that's talking about the whole genome rate, and he just does these apples to apples comparisons. So I think he's dealing with whole genome rates. So what I want to point out here is this. He does his pooled rate of an average substitution rate of 1 mutation for every 33 generations. So let's do our math on that. So let's take our 33 generations per mutation, multiply that by 60 mutations, multiply that by an average of 20 years per generation to get a time to most recent common ancestor of 39,600 years, which exceeds the young Earth timeline by more than 6 times. It's actually closer, in raw numbers, it's closer to the consensus range than it is to the young Earth range, which makes perfect sense. So that's a really fun example of a young Earth creationist not doing this math correctly, but doing it incorrectly for the way they wanted to do it, and ending up actually close to the correct answer. That's a fun example. I like it when creationists are accidentally correct like that. That's fun. So to summarize this video, young Earth creationists love to cite single-generation pedigree studies. They claim that these studies prove most recent common ancestors for the mitochondrial DNA and the Y chromosome. There are many problems in how they do this, including misrepresenting most recent common ancestors, ignoring autosomes, treating mutation rates as substitution rates, ignoring direct, independent confirmation of phylogenetic rates, counting somatic mutations, extrapolating the hypervariable region, and doing hilariously incorrect, let's call them calculations. But putting that all aside, we only focused in this video on how they cherry-pick single-generation pedigrees and ignore multi-generation pedigrees that disprove their recent dates for the Y chromosome and mitochondrial most recent common ancestors. So, do pedigree mutation rates prove a recent creation? No, they do not. That is a creation myth, and now you know why. So anytime this comes up in discussions involving young Earth creationists, don't give them an inch. Don't let them say pedigree mutation rates prove it, and you say, oh, well, you have to look at the substitution rates of the phyla. No, don't even let them get away with claiming pedigree mutation rates. They're just using single-generation pedigree mutation rates. There are other pedigrees out there that are just as direct, just as valid, and those disprove the young Earth creation dates. So use those data, refute those creationists. Thank you all for watching. I hope you enjoyed this. It turned out to be a little bit longer than I anticipated, went into a little more detail in a couple of places than I originally thought I would, but I hope you found it enjoyable and informative. If you liked this video, please hit the like button, leave a comment, and if you're not already subscribed to this channel, but you want more information on all the nonsense, all the garbage that young Earth creationists put out there and why it's wrong, hit the subscribe button and I will keep you supplied with the information for why young Earth creationism is nonsense. Thank you in particular to my channel members, in particular Charles and Ian, for your contributions. Remember, channel memberships are enabled. If you join at any level, you get access to my pre-recorded videos like this one immediately when I upload them, instead of having to wait for the public release. So thank you again for watching, everybody. This has been my longer than anticipated discussion of how creationists misuse pedigree mutation rates. Take that information and don't get fooled.